Hello students, today we'll solve one more problem from particle physics, and that question asked in CSIR NET 2015 June. So in that question, 2 deuterium decays to helium plus pi 0, and that reaction is not possible via strong interaction because it violates which conservation? Baryon, charge, angular momentum, or spin, isospin, that we have to check. So we'll check one by one. So let us check charge, or sorry, baryon first. Okay, so we know that deuterium on the 2 is made up of on proton, on neutron, and on electron, right? And helium is made up of 2 proton, 2 neutron, and 2 electron. Okay, so please note it. So deuterium have on proton, on neutron, on electron, and helium has 2 proton, 2 neutron, 2 electron. Okay, so let us check baryon, noted by capital B. So in deuterium you have 2 baryon, on proton and on neutron. So 2 plus 2 on the left hand side. On the right hand side you have helium. It has 4 baryon, and pi 0 is meson particle, so obviously that B will be 0. So you see, on the left hand side you have 4, on the right hand side you have 4. It means B is conserved. B means baryon. Now we'll check charge, noted by capital Q. Okay, so in deuterium you have on proton and on electron. Okay, so its charge is 0. So on the left hand side Q is 0, and same is true for right hand side, because helium has charge 0, net charge 0, and pi 0 is chargeless, right? It means again charge is conserved. Okay, now we'll check angular momentum or spin angular momentum. So deuterium basically found in triplet state, so it means its angular momentum or spin is on. Okay, so 2 deuterium you have, it means that this value is basically vector sum. Okay, so it means on plus on or on minus on. Okay, so on the right hand side you have helium, and that spin is 0, and same is true for pi 0 also. So this value can give on plus on or on minus on. On minus on will give 0 value, and that is possible. Okay, it means spin and corresponding angular momentum is conserved. So again angular momentum is conserved. Okay, now we check isospin, noted by capital I. Isospin of deuterium is 0. So on the left hand side this is 0, and isospin of helium again 0. But for pi 0 this value is on. So you see, on the left hand side I is 0, but on the right hand side I is on. It means I is not conserved. So this reaction is not possible by a strong interaction because it violates isospin.